Our final geometry topic involves the angles of a triangle. So first of all, there's a very simple rule that the angles of any triangle always add up to 180 degrees. We don't really need to belabor that point very much, but it is a really important fact to remember. So it can help us find missing angles, basically. But in this discussion, we're really going to focus on two special triangles. And they're going to be special because of their angles. So the first special triangle is the 45, 45, 90. It's shown here. It's named after its angles. So it has a 45-degree angle, another 45-degree angle, and then a 90. And you can check those all add up to 180. The other special triangle is the 30, 60, 90. So each one of these triangles has a certain proportionality to its sides. The sides always come in proportion to one another. As a matter of fact, that's true for any triangle, no matter what the angles are. But these are the only two triangles where we actually need to know those proportions. Otherwise, we'd be getting into trigonometry. And other than these two special cases, there's no trigonometry on the test. Okay, so take a look at the 45, 45, 90 triangle. You'll notice that I've labeled two of these legs as L. I've used the same letter. That's not a coincidence, because remember, same letter means same number. So this is the isosceles right triangle. Isosceles means two angles are the same, two sides are the same. So for example, if this side is 7, then this side is 7. And then your hypotenuse will have the formula h equals L times the square root of 2. So again, if you replace L with any number, then that number gets replaced in all three of these L's, right? So if this number becomes a 6, then this becomes a 6, and this becomes 6 times the square root of 2. Or if this L becomes a 5, if the hypotenuse is 5 times the square root of 2, then this is a 5, and that's a 5. So think about all those L's as changing to a number all at the same time. They all have to change together. Okay, and then on the 30, 60, 90 triangle, we have a short leg S, a long leg L, and a hypotenuse 2S. A hypotenuse H before we go into the formulas. So the formulas are the long leg equals the short leg times the square root of 3, and the hypotenuse equals twice the short leg. So again, you should think about these letter S's as all changing at the same time. If this S changes into a 4, then this suddenly becomes 4 times the square root of 3, and this suddenly becomes 2 times 4, which obviously is 8. The main problem that students have with these triangles is either mixing them up with each other, or maybe mixing up two sides with each other, or just not remembering it 100%. Basically, I guess the problem is that students kind of, sort of get this subject. If you feel that you kind of, sort of get this, then believe me, you don't, okay? There is no kind of, sort of here. These numbers need to be 100% exact. You can't mix them up with one another. I mean, let's face it, if you don't have these formulas down 100% accurately, you're going to get all the problems wrong. So these are really short, simple formulas. Please do yourself a favor and keep studying these until you don't get them mixed up anymore. For example, I'll have a student come into class and I'll put a 45, 45, 90 triangle on the board, and all of a sudden the student will start talking about the square root of 3. Oops, wrong triangle. Okay, you can't get them mixed up like that. Or I'll put one of these triangles on the board, and a student will get these two formulas mixed up with each other. Oops. Okay, just a little slip up, but now you're going to get 0% on your problem. So you have to be 100% exact in memorizing these formulas. It's not asking too much. All right, let's practice using them. Let's go to the board where I've duplicated these triangles. So the first one has a 45-degree angle in it. It's a right triangle. Has sides of 9, M, and N. So what would we know about this other angle? Well, the three angles of a triangle have to add up to 180, so this angle would have to be 45 as well. Okay, that makes us feel better. We know the 45, 45, 90 triangle. We know that each leg can be called L. They're the same. And we also know that the hypotenuse would be L times the square root of 2. So all the L's go together. If this L is 9, then so is this one. Okay, so N is 9. And this L would also be a 9. So the hypotenuse N of this triangle would be 9 times the square root of 2. I'm just changing all of the L's into 9s at the same time. L times the square root of 2. 9 times the square root of 2. Really, it's a really super simple idea. Okay, the next triangle is another right triangle with a 60-degree angle in it. What would that tell us about this angle? Well, they have to add up to 180, so this angle has to be 30 degrees. So now we know that we're looking at our 30, 60, 90 triangle. And we know that there are two formulas for that. We know that there is a short leg, S. We also know that the long leg is S times the square root of 3. And we know that the hypotenuse is twice the short leg. Because we have memorized those formulas 100% clearly. We don't ever get them mixed up. We don't kind of sort of know them. We totally 100% know them. If we're going to be ready for the GRE. Which one is the short leg? That one's a little trickier than this. Well, the short leg is always opposite the small angle. 30 degrees opens up to the short leg. So we will call this one S for short. I really recommend you do this, by the way, to be very clear which side is the short, which side is the long. The 60-degree angle opens up to the long leg. And the 90-degree angle opens up to the hypotenuse. Okay? So now we know which side is which. Now, the only number that we actually know as a constant is the hypotenuse 6. So if we're going to figure out the others, we'd better start with the formula that has h in it. Okay, so here's the formula, h equals 2s. What is h again in this triangle? 6. What is s again in this triangle? P. 6 equals 2p. How do we get p by itself? We divide by 2. P is 3. Okay, so now we're basically done with that part. We still need to find the long side, the long leg Q. So we need the formula with L in it. There it is. What is L in this triangle? Q. What is S in this triangle? 3. Q equals 3 times the square root of 3. If you know these ratios 100% perfectly, these problems are very easy. If you don't know these ratios at all, these problems are impossible. If you know these ratios kind of, sort of, then the problems might feel easy to you or they might feel hard, but you're going to get them wrong. So that's not acceptable. Okay, and then let's look at number 20. Number 20 asks us to find the angle, x degrees. And what we're given is a right triangle with side of 40 and a hypotenuse of 80. So when we look at this, we should recognize we're thinking about the ratio of these sides. The hypotenuse is twice as long as this side. When the hypotenuse is twice as long as one of the sides, we'll call it S, then it must be a 30, 60, 90 triangle. The angles and the ratios of the sides go together. So if this is a 30, 60, 90 triangle, the only other thing to figure out is which angle is the 30 and which one is the 60. Well, we remember that the short leg faces the 30-degree angle. So the 30 would be here. It opens up to the short leg. And therefore, this angle would be 60.